continue. Open the table of content first. Okay. Hopefully my internet connection is stable enough. Alright. We are still on chapter 26. Okay. Now let's take a look at this section 26.3, why it gets worse. Okay, 26. Alright. Yeah, okay. Okay, that creation. We have to take a look at that. Now let's take a look at this. Why it gets worse? Set data. The simple thread example we showed above was useful in showing how threads are created and how they can run in different order depending on how the scheduler decide to run them. What it doesn't show you, though, is how threads interact when they access set data. Let us imagine a simple example where two threads wish to update a global set variable. The code we'll study is in figure 26.6, page 7. Here are a few notes about the code. First, as Stephen suggests, okay, we wrap the thread creation and join routines to simply exit on failure. Okay, join routine to simply exit on failure. For a program as simple as this one, we want to at least notice an error occur. If it did, right? If the error occurs, but not do anything very smart about it. For example, just exit. Okay. Thus, pthread create simply calls pthread create and make sure the return code is 0. If it isn't, pthread create just prints a message and exit, right? Using assert, what is it called? System call is assert considered system call? Oh no, the library function. Yeah, we use this one to check whether the pthread create here, what is it called? Return 0. It means success. Okay. Okay. If it isn't, pthread just prints a message and exits. Second, instead of using two separate function bodies for the worker threads, we just use a single piece of code and pass the thread an argument, in this case a string, so we can have each thread print a different letter before each message. Okay, two separate function bodies for the worker thread. We just use a single piece of code and pass the thread an argument, in this case a string, so we can have each thread print a different letter before each message. Okay, a single piece of code and pass the thread an argument. This case a string, so we can have each thread print a different letter before each message. Finally, and most importantly, we can now look at what each worker is trying to do. Add a number to the set variable counter, and do so 10 million times, okay, in a loop. Thus the desired final result is this one. We now compile and run the program to see how it behaves. Sometimes everything works how we might expect. Okay. Oh, okay. Instead of using two spirit function bodies for the worker thread, we just use a single piece of code and pass the thread an argument. Okay. So I assume we use we use one abstraction, maybe something like that. We use an abstraction and then pass the thread as an argument. Okay. Maybe add number to the set variable counter 10 million times. Okay, the desired final result is this one. Sometimes everything works how we might expect. Done with both counter, okay. I think this one. Do we need the volatile here? I'm not sure. I mean, I've read somewhere that volatile might not have any effect in concurrency or maybe parallelism, but I'm still not sure. Do we need volatile here or not? Simply adds one to counter repeatedly in a loop. No, this is not how you would add 10 million to a counter, but it shows the problem nicely, okay. Alright. This make me wonder, rather than doing it like this, can we just use the plus counter maybe? Maybe there is some difference there. Okay. Alright. Begin arc. Okay. I mean, previously the argument is, what is it? A and B2, okay. I guess this is kind of the same except for this one, the looping maybe. Oh, also print done, okay. Just launch to thread, pthread create, pthread join. Okay, and then wait for them, okay. Alright, this one. Join waits for the thread to finish. With boot counter, okay. That make me wonder, do we need counter to be global, or maybe we can put that as static here. But then if it is static, we might not be able to access that, to share that. Okay. Unfortunately, when we run this code, even on a single processor, we don't necessarily get the desired result. Sometimes we get, okay, this one. But the order is the same, I guess. Begin, and then A done, B done, right? A begin, B begin, A done, and then B done. Okay. Not only is it's run wrong, but also yields a different result. A big question remains, why does this happen? Did no end user tool, wait. Oh, okay. Did no end user tools. You should always learn new tools that help you write, debug, and understand computer system. Here we use a neat tool called disassembler. When you run a disassembler on an executable, it shows you what assembly instructions make up the program. For example, if we wish to understand the low-level code to update a counter, as in our example, we run object dump on Linux to see the assembly code, like this, for example. Doing so produces a long listing of all the instructions in the program neatly labeled, particularly if you compile with the -G flag. I think the debug flag, if I remember correctly, which includes symbol information in the program. The object dump program is just one of many tools you should learn how to use. A debugger like GDB, memory profiler like Valgrind, which we take a look on the previous chapter, or Purify, which I haven't taken a look yet, if I remember correctly. And of course the compiler itself are others that you should spend time to learn more about. The better you are using at your tools, the better system you'll be able to build. Alright, you know what? Let's check this out. Okay. Chapter 26. T1C. Alright, let me open this one. Okay. Yeah, void pointer, my thread. I need to make the function prototype first and then to find that later on. Just personal preference, I guess. I don't know. Okay. Then yeah, we need what is it? We need to scope a variable counter. We can omit static, I guess, but in this case I'm putting static so that this counter variable is only in this, what is it called, in this file, maybe something like that, or translation unit, maybe that's the term. I kind of forgot about the term there. makes me wonder what is this second is about, Instead of using two separate function parties for the worker thread, we just use a single piece of code and pass the thread an argument. Okay. I mean, previously wait, does that mean let me think. That good. Yeah, I'm still not understand. I still don't understand this one. Instead of using two separate function parties for worker thread, just use a single piece of code and pass the thread an argument. So we can have each thread print a different letter before each message. Before each message. Maybe something like this. But yeah, I'm not really sure what this is about. A single piece of code and pass the thread an argument. This is a string, so we can have each thread print a different letter before each message. Before each message. Is it this one maybe? Yeah, I'm not sure. Okay, let me check counter right begin well. Guess let me do this do it like this. What should I call this? Thread or message or maybe section. Yeah, maybe let's call this section, and then of course don't forget about this one. Oh, I didn't know we can do this. Okay. Yeah, first let's try using this notation and then trying using this ++1. Counter plus, okay. Something like that. Oh, right. I forgot about this. Begin section, maybe something like that. Maybe we don't need that in the new line. TIO, and then probably I need the error node again. String vthread v1 v2, declare that, and then print f, bikin counter. Okay, bikin counter. Okay, and then right, what is it called? Return value there. Return value. Create. Null, right? Okay. Similar to the previous one, except that we add counter here, I guess. My thread. Maybe I can do this. B, and then okay. Join waits for the thread to finish. Okay, not that one. Yeah, I'm kind of curious how to make sure that thread 2 run first before thread 1. I haven't taken a look at that yet. Okay, something like this, and then done with both. Without threads. Okay. Counter. Chapter 26. And then T1. Okay, unclear. Right. Okay. This one, right? fault. Oh, wait a minute. Okay, because of this one. Probably because this one already finished. Maybe that one already finished, but we are trying to use that thread again. Interesting. Yeah, why this one causing problem? Let me check. Is that great? Okay. Right, segmentation fault. Successful call. Okay. Start execution by invoking start routine. This one. Let me take notes first. Why using with P1 of P2 here after seg fault. Okay. Yeah, the counter. What is it called? Did not appear as expected. Right. Not only is its run wrong, but also yields different result. I assume it is because it is not atomic. So its thread might replace the state of this counter. And then, well, what is it called? That cause the last state change between thread. Let's say the first, when we increase the counter in thread 1 here from 0 to 1, this thread 2 still having the zero number in the counter. So after we increase the counter in here, this P2 replace the last or the previous value from this thread, maybe something like that, with the current value in the thread 2 here. If I remember correctly, it is called atomic or something like that. Maybe. Wait, let me try using this one. Alright. Oh, interesting. Okay. In this case, for whatever reason, B thread done first and then A thread. Is it always the case? Not always. Okay. That is interesting. And well, let me try. Okay. So this one doesn't have any effect, I guess. At least from what I observe here. Done, then done. Yeah, that is interesting. Okay, and then let me check. P-thread. Well, I guess I can check with GTP for this one. A symptom of memory corruption elsewhere in the program. Okay. Very first invalid memory access. It's because you didn't declare variable. Okay. Contains garbage value. Oh. The wrong address. Let me try. What's declare here? Maybe use. Oh, okay. Yeah. Alright. It looks like the one causing problem is from this one because it is uninitialized, so we have no idea what's in there. try checking that with GTP, I guess. Should I just run? No. Okay, right, segmentation fault. Can I use this? Insufficient. Oh. Interesting. Okay. Maybe let's add breakpoint here. Okay. Where is it again? Break 66 here. Okay, and then run. No. Hit breakpoint. Okay. Alright, I guess in this one, right? Now let's next, I guess. Okay. Receive segmentation fault. Okay. Yep, that's why. That's where the segmentation fault happened. Basically, we are trying to use an initialized P2 variable here with the P2 join. Alright. Okay. Check them. Let me check. If I remember correctly, previously I tried this out. Oh, there is disassemble and disassemble. Oh. Okay. Disassemble 0. Okay. But disassemble the content of all non-empty, not just those expected to contains instruction. Okay. Alright. The heart of the problem, uncontrolled scheduling. Should we try using disassemble object dump here? Maybe. Take them. The one here. am still not sure about the section here. Section PRT init. Maybe this is the label, something like that. This is the start. I assume the main, when we call the main function, this one. Okay. Alright. Yeah, I'm still not sure how to read this yet, at least. Okay, uncontrolled scheduling. Okay. Yeah, the atomic, right? Okay, well, I guess let's continue this on the next session. Looks like we are gonna take a look at some assembly here. Okay, so let's continue this on the next session. That's it for now. Thank you for watching and see you next time. Bye bye.